Alrighty, and good morning. Happy Friday. Today we're going to have a short lesson on multiplying, dividing, adding, and subtracting rational numbers. So we're going to work on adding and subtracting fractions. And then we're going to work on multiplying and dividing specifically with decimals a little bit today. So it's going to be a short lesson, and then we have a quiz game for the homework assignment. That'll be open for a while, just to make things a little bit more fun rather than just work. All work and no play makes Jack a dull boy, you know? So what we're going to do here is just real quick. I'm going to ask you pause for a minute and try to answer these questions. So you've had a moment now to try to answer these. Now you might remember how to do this and you might not. So actually, rather than a text box, let's look at it. We have these terms right here. These are called the numerator. Big fancy word. What we're going to end up doing, what that means is the top of the fraction. The bottom is called the denominator. The denominator. Numerator, top, denominator, bottom. When we're adding or subtracting, we just add or subtract the numerator. That makes this 7, and this stays 8. That makes this 6, and this stays 4. So you might actually write this as 1 and 1/2 would be a simplified version of this fraction, because this is an improper fraction right now. And 3/8 minus 1/8, well, we'd get 2 when we subtract the numerator. 3 minus 1 is 2. 2/8 or 1/4. So check what you did. Hopefully you got those answers. Now let's take a look at these. What do we notice about our denominators? They're not the same. So when we have a denominator that's not the same, you guys might remember this. We look for the least common denominator. So what we have to do with one of these fractions is we have to multiply it by a different number to get the denominators equal. For this one right here, you can actually take a look real quick. See if you can do the first one on your own. Pause real quick. All right, thanks for trying. So maybe you got this, maybe you didn't. Let's go ahead and do it now. You might take a look at this and notice you can make this 4 into an 8. What would you do to do that? You'd have to multiply it by 2, right? When I multiply this by 2, I'm going to get 3 over 4 times 2. We're going to end up with 6 over 8. So the least common denominator is 8. Now, there's just a comma in between them. They're not asking us to add, subtract, or anything. This is just finding the least common denominator. That's an easy one. We multiplied by 2. Take a look at this one over here. It's a little more difficult. Go ahead and pause. See if you can find the least common denominator. All right, thanks for trying there. So again, we have 5 and 7. 5 doesn't multiply by anything to equal 7. We can look 10, 15, 20, 25, multiples of 5. Here's a trick sometimes. On this one, you can go ahead and you can just count by the number, right? 5, 10, 15, 20, 25, 30, 35, and so on. Let's do the same thing with 7. Multiply it by 2, it's 14, 21, 28, 35. So we get 35. They both have 35. So my least common denominator that we were looking for is 35. In this circumstance, how could I have found that number? What would happen if I multiplied 5 times 7? We'd get 35. If you multiply your denominators, you're always going to get a common denominator. It might not always be the least common denominator, though. Here, if I multiply 4 by 8, it's 32, which is a lot bigger than 8. So that's not always going to get you the least common denominator, but it will always get you a common denominator. We could multiply the other two numbers as well and put them as fractions, but we're just going to move on for time's sake here because we were just looking for the least common denominator. We're going to do that a little more on the next slide here. So here we have to find the least common denominator before we do a math operation. So go ahead and try to do number 6 for me real quick. Go ahead and pause. All right, thanks for giving that a try, guys. So we have 1/2 and 2/3. My least common denominator, you guys probably found 6, right? 1/2. If I want to make 6 on the bottom, I have to multiply this fraction by 3/3. Remember, 3/3 is 1. So when I multiply this fraction by 3/3, I'm going to get 3 times 1. 3 times 1 equals 3. 3 times 2 equals 6. This is what's called an equivalent fraction, right? Because 3/3 is technically the number 1. So I didn't actually change the value. It's just displayed differently. Now to make 3 6, I'm going to have to multiply this thing by 2/2, right? So plus, now we're going to have 2 times 1 is 2, and on the bottom, the denominator, 3 times 2 is 6. So right here, we're actually practicing two skills, right? Adding fractions and multiplying fractions, right? So this is kind of fun. At least I think it is. Now I'm going to just add the numerators. Equals 5/6. What fun, right? Don't you wish we could do this every day? You probably could. The internet has plenty of math problems. All right, now I want you real quick, try number 7. This is a little more difficult. Okay, thanks for giving that a try. So we might have found 21 as our greatest common denominator. So to make 7/21, I have to multiply this side by 3/3. And I'm going to get 9/21. Right? That's 9. 3 times 3 is 9. 3 times 7 is 21. 2/3, to get 3 in the bottom to be 21, I'd multiply that by 7. So now we have minus 2 times 7 is 14. Remember, when we're multiplying fractions, we multiply the top, the numerator, and then we multiply the denominator. 3 times 7 is 21. So with addition and subtraction, though, I only add or subtract the numerator. My denominator stays the same. 9 minus 14 is -5. So our answer is -5/21. What happens if there's mixed numbers? For time's sake here today, we're going to just do one of these real quick. So if there's mixed numbers, we have two different choices. One is we can take the whole numbers and add them, and then add the fractions. That's choice number 1. So I want you to do number 8 however you'd like. Thanks for trying that one. So for this one, actually I'm going to do 8 and then I'm going to do 9, just so I can do both techniques. I'm going to add the whole numbers. 2 plus 5 is 7, plus I'm going to do the fractions now. So let's look at 1/2 and 1/3. We've actually done this, haven't we? I'm a little lazy, so we did that right here. 1/2 plus 1/3 is 5/6, right? We did that in the last slide. 1/2 plus 1/3, so 7 plus 5/6. So I added the whole numbers, then I added the fractions. So we'd get 7 and 5/6. My 6 isn't very good. I'm not going to redo it though. Now this next one, we're going to do it as making it a improper fraction. So for an improper fraction, now 3. What if I wanted to rewrite 3 as a fraction over 5? 3 over 1, we really think about as 3 over 1 times 5 over 5. So to make this an improper fraction, the 3 becomes 15 over 5. 3 over 1 becomes 15 over 5, which becomes 17 over 5, not equals. So 3, because 15 over 5 isn't equal 17 over 5. But we could rewrite this as 17 over 5. 1 over 1 is the same as 10 over 1. 10 over 10, sorry, not 10 over 1. So we could rewrite this as 13 over 10. We still have one last step. We need to find our least common denominator, not the greatest common factor. That's algebra right now. All right, so 5 and 10. What do they have in common? What's their least common denominator? It's actually going to be 10, right? So 17 over 5 times 2 over 2, because that is what makes this 10, is 34 over 10 minus 13 over 10. And what we're going to get here on the bottom here, what you hopefully got before me, 34 minus 13 is 21. Blackjack. All right. So we're going to go. All right, welcome back. And our objective here is going to be multiplying and dividing with decimals. So we're just going to do one problem with each real quick. It's going to be a real fast separate lesson for today. We did addition, subtraction the other video. So step 1, we're going to just do long multiplication like we normally would. I'm going to write this in a text box over here. We have 2.7 times 3.5. 2.7 times 3.5. And when we do this, we get everything lined up here. Thanks for your patience. And we're going to multiply the 5 by 7 first, right? 5 times 7 is 35. Now we're going to do 5 times the 2. 5 times 2 is 10. We put a 0. Sorry, we put the 0 there first, though, right? We put a 0 there first because it's in the second place. 5 times 20 is what we think about that as, right? Now, let's take a look right here. We're going to put a 0, right? Because we're 1 over. This is like a 30. It's like 30 times 7. Or we put the 0 there already, and we do 3 times 7 is 210. And 3 times 2, we're going to put 2 zeros, right? And we get 3, or 30 times 20, we can think of it as 3 times 2 is 600, right? That's how we do our long division. We put a 0 there when we're multiplying this 3 by this 7, because there's a place here, right, where the 5 is, we put that 0 behind the 21, right? So that's our long division answer. We add all of these numbers up. Now we go down each column. 5, 3, 0, 1, and 0 is 4. And then 1, 2, and 6 is 9. 945. But wait a second. That doesn't make sense because 2.7 is less than 3, and 3.5 is less than 4. 3 times 4 is 12. These numbers are less than those two, so this can't be equal to 945, can it? No, not really, right? So how do we know where these decimals go into our answer? There's a really simple rule. We're going to come back to this slide in a second. It says we count the number of decimals in the problem, or the numbers of digits behind a decimal point. There's 1. This is behind a decimal point. And 2. This is behind a decimal point. Okay, so that's step 2 is I count the digits behind the decimal. And then I put the decimal point in the answer. Your answer should have the same number of decimal points, the same number of digits behind decimal points we had in the problem. So if my problem had 2 digits behind a decimal point, my answer should have 2 digits behind a decimal point. If I had 3 digits behind a decimal point, my answer should have 3 digits behind a decimal point. So let's take a look real quick. If I put it right here, 9.45. 9.45. I know my decimal leaves something to be wanted. 9.45. So how do I know where my decimal place goes? How many digits should I have behind it? I count that there were 1, 2 digits behind it in the problem, so my answer should have 2 digits behind it. That's all there is to it. So you're going to practice this skill in the quiz game in a little bit. So let's just use that skill real quick. I'm not going to make you do the long multiplication here. But just use that rule. Count the decimal places behind, or the digits behind decimal places, and then figure out which of these 3 answers make sense. So go ahead and pause real quick and try it. All right, thanks for taking your time. So we have 1, 2, 3 digits behind decimal places, and here there's 1, 2, 3 digits behind decimal places. It's that easy. So this one right here is the correct answer. It's the only one that could be correct. Because there's got to be 3 digits behind decimal places. Exciting stuff. Thank you, guys. All right. So then long division. Follow these steps. You'll be great at dividing decimals. Real quick reminder. Some vocabulary. The quotient is the number up top. It's your answer. The divisor is the number outside. It's the number you're dividing by. And the dividend is the number that's being divided. All right. It's inside here is the dividend, outside is your divisor. The roof, which is on fire in some situations, hopefully not this one, is the quotient. So 12.64 divided by 2, 12.64 divided by 2, 12.64 divided by 2, they all mean the same thing. Knowing that all 3 of these things, they're all the same thing, that's important, guys. So steps in dividing a decimal, you can pause it and read all of this real quick. We're going to go ahead and we're going to explain this by doing it. Pause it and read this if you want. I'm not going to read the whole thing. We're going to go ahead and use these steps. So swinging monkeys. We're going to swing the decimal place 1 spot to the right. We're going to make 0.2 into 2. But wait a second. I can't just change one number without changing the other number. The golden rule of algebra is if we do something to one thing, we're going to have to do it to others. Otherwise, the values are going to change. So we're going to swing the other one 1 place to the right. However many places to the right we have to swing it, our goal is I want to make 0.2 a whole number. Then I'm not dividing by a decimal. I'm dividing by an integer. which I know you guys know how to do a lot better. I do too. So once we've swung them both, we're going to also put a decimal place on the roof, which is on fire, which is where the quotient is going to go. That lines up with the swung or new decimal. After that, we're going to divide as normal. So remember, when we do long division, I asked, does 2 go into 1? No. Does 2 go into 12? Does 2 go into 12? Sure. 6 times, right? Now does 2 go into 6 down here? 3 times. And does 2, then there's none left, right? There's nothing left over. Nothing carries over here. And does 2 go into 4? It does twice. So our answer should be 63.2. So the difficult part is doing our swinging of the decimal places. Once we do that, we know how to divide a number by 2 or 3 or 4 or even 7. Hopefully not 9. When we're getting up to pretty big numbers. You guys will be able to use a calculator, of course, on the quiz game later, but just a quick refresher on how to do this by hand. And that is our last little step here. So if you guys have any questions, email me. I know you guys can do it. Have fun with the quiz game. Thanks and have a great